is Atikah Binti Khalid. This is Muhammad Hakimi bin Abdul Munir. This is Marina binti Mahather. This is Muhammad Hazrin bin Halmi. And this is Danieal Hazziq bin Mohammad Zahir. In the real life, we have links with limited bandwidth. Bandwidth is the most precious resources in the data communication. In the analog signal, bandwidth is the range of frequency, while in the digital signal, bandwidth is the bit rate. The wise use of bandwidth has always been the main challenges in the electronic communication. But the word wise depends on the application. Sometimes we need to use several low bandwidth channels to make use of one channel with a larger bandwidth. And sometimes we need to expand bandwidth of a channel to achieve goals like privacy and anti-jamming. I will explain to you guys the two broad categories of bandwidth utilization, which are multiplexing and spreading. In multiplexing, our goal is the efficiency. We combine several channels into one. Whenever the bandwidth needs of a medium linked to devices is greater than the bandwidth needs of the devices, the link can be shared. Multiplexing is a set of techniques that allow simultaneous transmission of multiple signals across a single data link. As data and telecommunications use increases, so does the traffic. We can accommodate by continuing to add individual links each time a new channel is needed, or install higher bandwidth links and use to carry multiple signals. The three basic multiplexing techniques are the frequency division multiplexing, wavelength division multiplexing, and the time division multiplexing. The first two multiplexing techniques are for analog signal, and the third multiplexing technique are for the digital signals.
First technique in multiplexing is frequency division multiplexing. Okay guys, what is FDM? FDM is frequency division multiplexing. When the carrier is frequency, FDM is used. FDM is an analog technology that divides the spectrum or carrier bandwidth in logical channel and allocates one user to each channel. Each user can use the channel frequency independently and has exclusive access of it. All channels are divided in such a way that they do not overlap with each other. Channels are separated by guide bands. Guide band is a frequency which is not used by either channel. What is the use of FDM? A common example of FDM use is cable television, CATV. This can be achieved with coaxial cable or fiber optic cable. A multiplexer is used to combine many channels to maximize the use of the available bandwidth, and a demultiplexer built into the television or set-top box will separate the channel that the viewer wants to watch. The advantage of FDM. There are four advantages of FDM. Firstly, a large number of signals or channels can be transmitted simultaneously. Number two, FDM does not need synchronization between its transmitter and receiver for proper operation. Number three, demodulation of FDM is easy. And number four, due to slow narrowband fading, only a single channel gets affected. The disadvantage of FDM. The communication channel must have a very large bandwidth. Intermodulation distortion take place. Number 3, large number of modulators and filters are required. Number 4, FDM suffers from the problem of crosstalk. And number 5, all the FDM channels get affected due to wideband fading. The application for FDM. Number 1, FDM is used for FM and AM radio broadcasting. Each AM and FM radio station uses a different carrier frequency. In AM broadcasting, these frequencies use a special band from 530 to 1700 kHz. All these signals or frequencies are multiplexed and are transmitted in air. A receiver receives all these signals but tunes only one which is required. Similarly, FM broadcasting uses a bandwidth of 88 to 100 108 MHz. Number 2, FDM is used in television broadcasting. And number 3, first generation cellular telephone also use FDM.
The second technique is WDM. WDM stands for wavelength division multiplexing. WDM has relation with refraction of light. This on the diagram, light is refracted through prism. The output light is separated to several lines of light that has different frequency. When we go deeper to multiplexing, it has same concept with refraction of light, where they are combining several lines into one. WDM is designed to use high data rate capability of fiber optic cable. WDM is conceptually same as FDM, except that multiplexing and demultiplexing involve optical signals through fiber optic channels. Derived from that, multiplexing actually has two elements. First is multiplexer on the sender side, and second is demultiplexer on the receiver side. On the sender side, narrow bands of light are combined to make wider band of light, and at the receiver side, the signal are separated by demultiplexer. The applications of WDM is a network. Multiple optical fiber lines are multiplexed and demultiplexed. The advantages of WDM: first, it has greater transmission capacity. Second, it has a duplex transmission. Third, the simultaneous transmissions of various signals. Fourth is lower cost. And the last one is faster access to new channel. However, the disadvantages of WDM is: first, it is do not cost effective for low channels. Second, it has a complicated transmitter and receiver. Third, the frequency domain involved in the network design and management, which increase the difficulty for implementation. In a nutshell, WDM is a technology of combining a number of wavelengths onto same fiber is known WDM. It is a basic technology of optical networking. In WDM, multiple optical carriers at different wavelengths are modulated by using independent electrical bit streams and are then transmitted over the same fiber.
Time division multiplexing, TDM. So, what is TDM? TDM is basically a technique for combining several low rate channels into one high rate. TDM also a digital process that the data rate capacity of transmission medium is more than the data rate required by sending and receiving device. Look at the diagram. Mux is a sender and Dmux is a receiver. So, multiple transmission can occupy at a single link by subwiring and interleaving into portions. Synchronous TDM. In synchronous TDMs, it will allocate exactly the same time slot to each device at all times. So, what is frame? Frame is time slot from each channel are grouped into frames. A frame consists of one complete cycle of time slots. In a system with an input line, each frame has at least n slot. So there's 3 input C, A, and B. In one frame, there's 3 input, like the example below: A1, B1, and C1. Interleaving. Synchronous TDM can compare to fast rotating switch. The switch moves from one device to another at constant rate and fixed order. Framing bits. No addressing required. Do you know why? Because the order of the receipt tells the multiplexer where each time slot located.
In spreading, our goals are privacy and anti-jamming. We expand bandwidth of a channel to insert redundancy. In spread spectrum, we combine signal from different sources to feed into larger bandwidth. It is designed to be used in the wireless applications such as LANs and WANs. The wireless application use air or vacuum as a medium of communication for all the stations. The station must be able to share medium without interception by eavesdropper, which are the unauthorized real-time interception on the private communication, and without being subject to jamming from dangerous unknown intruder. To achieve goals, spread spectrum techniques add redundancy. They spread the original spectrum needed for each station. The expanded bandwidth allows the source to wrap its messages in the protective envelope for more secure transmission. We can see this from an analogy, which is the sending of delicate and expensive gift. By inserting the gift in the special box to prevent it from damage during the transportation, and use superior delivery service to guarantee the safety of the package. In spreading process, it uses spreading code and spreads the bandwidth. Spreading code is a series of numbers that looks random, but it is actually a pattern. The two techniques to spread the bandwidth are the frequency hopping spread spectrum and the direct sequence spread spectrum.
Frequency hopping spectrum, or FHSS, is one of the spread spectrum technique. The idea of frequency hopping is that the original signal will be modulated by multiple different levels of frequency in pseudo-random sequence. What is pseudo-random, you might ask? Pseudo-random is an arrangement in random but has a predictable sequence. One hopping from one frequency to another, called as dwell time. Now, let's jump right into the components of FHSS. In FHSS, there are four components that play the roles in the process, which are pseudo-noise, frequency table, frequency synthesizer, and modulator. The first one is pseudo-noise, also known as pseudo-random code generator. The function of pseudo-noise is to generate random predictable pattern in bits form. One bit will change to another bit in every dwell time. The sequence will repeat itself when sequence ended. For example, there are 8 different levels of frequency and the first bit in the sequence is 101. After a dwell time, it will go to the next bit in the sequence, which in this example is 111, and so on. After the very end of the sequence, which is 000, it will start back at 101. The second component is frequency table. The frequency table will be as reference for choosing the frequency channel based on pseudo-noise. Each bit has been assigned to a specific frequency. Let's create an example of frequency table. If the sequence of bit of the pseudo-noise currently is 100, the frequency to be modulated, the original signal will be 600. So let's move to the third component, which is frequency synthesizer. After the frequency is generated, it will send to the modulator. And here comes the last part of the components, which is the modulator. The function of the modulator is to modulate the original signal based on frequency created by the frequency synthesizer. Now we are going to the third subtopic, which is bandwidth sharing. The concept of bandwidth sharing is to multiplexing different FHSS into one single bandwidth. This is possible because there is only one FHSS frequency in one dwell time. For example, the total number of hopping frequency is 8. Hence, there will be 7 slots for other frequency to be fit into the bandwidth of 8 frequency in one dwell time. Now let's go to the second technique, which is direct spread spectrum. Direct spread spectrum will expand the bandwidth same as FHSS but in different way. The idea of DSS is spreading a number of bits to be assigned to one bit of information. The code of number of bits are called chips. For example, to make understanding better, let's say the spreading code has 11 bits. So there are 11 bits represent one bit of information. Let's see the example through a graph here. This graph uses non-written zero encoding for both original signals and spreading code signals. As you can see here, the bit 0 of original signal will be modulated by the spreading code here and create the spread signal like at the bottom of the graph. Since the spread code has 11 bits, the rate of spread signal will be 11 times more than original signals. If the original signals is 1 bit per second, the spread code will be 11 bit per second. Plus, the bandwidth also will be 11 times larger compared to the original bandwidth.